Hi everyone, let's continue. So last time we talked about the curvature. So the curvature answers the questions about how fast a curve turns. Then the principal unit normal vector determines the direction in which a curve turns. Okay, so we know a curve turns, it can turn to the left or it can turn to the right? So let gamma of t describe a smooth parametrized curve. The principal unit normal vector at a point P on the curve at which the curvature is not zero equals, okay, and we use n to denote the principal unit normal vector. That is the derivative of the unit tangent vector with respect to the outline parameter s, and then divided by the magnitude of this quantity. Okay, so last time we talked about the magnitude of the derivative of the unit tangent vector with respect to the outline parameter s is the curvature. Okay, so we can use other parameter as well. Okay, we can use t as well. So this is the formula. So is t prime over the magnitude of t prime. Okay, so this is the formula of the principal unit normal vector. So suppose we have a curve at this point P, then what is t? This is t, okay? T is the unit tangent vector, and then what is the n? Well, n is perpendicular to the unit tangent vector, and the magnitude of the unit normal vector is 1, okay, and it's pointing to the direction which you turned. You can see this point is turning to the right. Or if we have a curve look like this, you can see at this point is turning to the left, so the n is right here. At this point is turning to the right, so the n is right here. So far so good, everybody? Okay, so notice that the unit tangent vector t and the principal normal vector n are orthogonal at all points of the curve. So why is that? Okay, so we know that the unit tangent vector, because it's unit, so the magnitude is fixed, is 1, right? And last time we showed something similar to this. If this is 1, then because 1 is the magnitude square is t dot t. When we differentiate, we get 0 equals t prime dot t plus t dot t prime. So that's why t prime dot t is 0. Okay, but your n and is just t prime over the magnitude of t prime. So they're in the same direction. That's why n dot t is also 0. So far so good. So n points to the inside of the curve. So that is the direction that the curve is turning. Okay. I have a typo here. Okay. So let me show you some picture. So on our course website, you can see we have 3 extra credit projects using the GeoGebra to draw parametric curves. This is our first project. Second project, use GeoGebra to draw 3D curves and surface. And last project, use GeoGebra to draw vector fields and gradient fields. So here is the instruction. So please download GeoGebra Classic 6, okay, in your computer, no matter you use Windows or ISO, so you can both download it. And then watch these videos. So I have a YouTube video show you how to graph those curves and create those vectors. And then we have the animations.
Hi everyone, in this week.
Okay, and then I also give you the step-by-step screenshots about how to compute. Okay, and at the end, what do you get? So this is our example. You can see here, when the point is moving, we have the unit tangent vector t and the principal unit normal vector n. Okay, so can you see when it goes around, you can see how the n and t changes. And furthermore, this is another example. Sorry, it's loading. Let me reload this page. Okay, so you can see this is the curve. Okay, and when it goes around, you can see how the unit tangent vector and the principal unit normal vector changes. Okay, and they are both unit vectors, which means the magnitudes of them are 1. Okay, but it shows direction. Okay, so let's come back. Let's continue with our example. Find the principal normal unit normal vector of the helix. Okay, so let me change back to orange color. Okay, so first we want to compute gamma prime, that is the velocity. So derivative of cosine is minus sine. Derivative of sine is cosine. Derivative of bt is b. And then, what is the speed? So this is the tangent vector, right? What is the speed? Well, this is square root of a squared sine squared plus a squared cosine squared plus b squared. Well then, because a sine squared plus cosine squared is 1, so this is just a squared plus b squared, right? And then what is our unit tangent vector? Well, is each coordinate divided by the speed. Okay, next we want to calculate t prime. So what is t prime? You're going to take the derivative. Well, here a and b, they're just constants, right? Derivative of sine is cosine, so become cosine t a squared plus b squared. Derivative of cosine is minus sine, so sine t a squared plus b squared. This is a constant. Derivative of constant is 0. Okay, now what is the magnitude of this guy, t prime? Well, is the square root of each guy squared, so a squared cosine squared over a squared plus b squared plus a squared sine squared over a squared plus b squared and plus 0, right? And you can see we can combine them, and sine squared plus cosine squared is 1, so we just get square root of a squared, which is a, if we assume a and b are positive. And then the bottom we have square root of a squared plus b squared. Okay, so finally our n is t prime over the magnitude of t prime. So, which means, you see, we divided by this guy, and this guy is here. Okay, when we divide by it, we only see the cosine and sine, so minus cosine t minus sine t and 0. So this is the principal unit normal vector. So far so good. So it gives us the direction in which the curve is turning. Next topic, components of acceleration. The acceleration vector of an object moving in space along a smooth curve has tangential components in the direction of the tangent vector and the normal component an in the direction of n. Okay, so let me draw a picture here. So what is v? V is the tangent vector. What is n? Well, t. T is the unit tangent vector. So the magnitude of it equals 1. And what is n? N is the principled unit normal vector. So this is the n. So it measures how fast this, it gives this direction in which the curve is turning. Excuse me. Okay, let me draw a better one here. Okay, now how about the acceleration? Well, acceleration, let's say, is like here. Okay, so let's say this is the acceleration. Okay, then we can decompose into two components. AT, so AT is a number, okay? So this component is actually AT times t. So a vector has magnitude and has direction. So it's in the direction as the unit tangent vector, and the magnitude is AT. And then the other component, this component is AN. Okay, so AN is the, AN is the magnitude, okay? So AN times N is a vector, okay, in the direction of the principled unit normal vector. So AT measures, acceleration, it measures like change of the velocity. So AT, it denotes the portion of the acceleration we use it to change the speed. Okay, so velocity, for velocity we have the speed and the direction. Okay, so measure how we change the speed. Okay, and AN, it measures how we change the direction. So far so good, everybody? Okay, so that's why, how do we measure AT? AT is we use A dot T. Okay, remember that A dot T equals A T cosine theta, where theta is the angle between them, right? But because the magnitude of T is 1 because it's a unit tangent vector, is a unit vector. So that's why this guy is actually the projection of the acceleration onto the unit tangent vector. Okay, so this is the projection of A onto the unit tangent vector. Okay, so and this guy is the projection of A on to the principled unit normal vector. Okay, let's continue. Let's work on these problems. A particle is traveling along a parabola t squared. For 2 less than equal to t less than equal to 2, find the tangential and normal components of the acceleration. Okay. First, What is V? V is gamma prime. Derivative of t is 1. Derivative of t squared is 2t. What is A? Well, A is gamma prime prime. So derivative of 1, 0. Derivative of 2t is 2. Okay. Next, we want to find. So there are two ways to find AT. Okay, we can find the principal the unit tangent vector, and then we can use A dot unit tangent vector to find AT. And there is another way. Okay, you can differentiate the speed. Okay, because it measures how the speed changes, right? So that's why this one way. Second way, AT is we take the derivative of the speed. So in this case, let's look at the speed. The speed in this case is square root of 1 squared plus 2t squared. That's the same as 1 plus 4t squared. Okay, let's continue and let's see here. So what is the derivative of the speed then? It equals, well, chain rule, this is like 1/2, 1 plus 4t squared to the minus 1/2 times 4t squared prime. Well, that is 8t, right? So we have 2, this is square root of 1 plus 4t squared. Well, the 8t, 2 and 8 cancel, we get 4 on top. So that's why we have 4t over square root of 1 plus 4t squared. So far, so good, everybody? All right. And how do we calculate AN? Well, AN, also two ways. You can calculate the N. Okay, and then you use A dot N, you can calculate it. Well, the second way to calculate is using this method. Okay, so we use A equals V, the magnitude of that divided by speed. Okay, so in this problem, let's use the second way, okay? And then in the next example, I will show you the first way. Okay, so in this example, let's both use the second method. Okay, so let's see, what's A equals V? I, J, K. And here, because cross product is in space, okay, so this is in space, you can consider this particle is traveling on the xy plane in the space. So then you can imagine the V has, if they're in the space, is 1, 2t, and 0. Okay, it's on the xy plane in the space. Then A, we have 0, 2, 0. Okay, now what happened? Well, the minor, so it's 2t, 2, 0, 0. So plus, minus, plus. This is the minor. Okay, and then what is the next? Well, next is this guy and this guy. So you see, cancel it. And K is 1, 0, 2, T, 2. And if in a matrix, it consists of a row entirely of zeros or a column entirely of zeros, the determinant is 0. So you can see this guy is 0, this guy is 0, and this guy is 2k, right? So the magnitude of A equals V is 2. So far, so good, everybody. So now an is 2 over, what is the speed? We already have the speed. 1 plus 4t squared. So far, so good. Now we're done. Because now a is at, or at is 4t over square root of 1 plus 4t squared. T plus an. Let me move this guy here. An is 2 let me see. Okay, so 2 over square root of 1 plus 4t squared n. Okay, so this is the acceleration. Okay, let's continue. Example, at a certain moment along some trajectory, v equals 3i, 5j, 2k, and a is 7i minus 2j plus 4k. Find at, an, t, and n at this time. Okay, so you see what we have done before. We're given the function. Okay, we're given the parameterization gamma of t is a function of t, is a vector value function of t. So we can take the derivative, we can find v, we can find a, we can find the unit tangent vector t, and we can find the principal unit normal vector t. Okay, but here we're not given a function, we're only given some information at a particular point. So then how do we figure out the rest? Okay, so in this problem, it's good to draw it and understand it. Okay, so if we're given v, what can you find for those information? Oh, you can find t, right? You can find t here. So we have v, then we can measure the magnitude of v. Well, that is 3 squared plus 5 squared plus negative 2 squared is the same as 2 squared. So 9, 25, and 4. That gives us 38. Okay, good. So then our unit tangent vector equals the v divided by the speed. Okay, so we have 3 over square root of 38, 5 over square root of 38, negative 2 over square root of 38. So far, so good. This is the unit tangent vector. All right, and then we have the a, right? So we have the a. This is the a, and then we can find two components, the tangential component and the normal component. Okay, how can we find the tangential component? Well, here we know a and we know t, then we can find the tangential component. Okay, so a and at, the tangential component, equals a dot t. Well, a dot t, a is 7, negative 2, 4, dot t, 3, square root of 38, 5, square root of 38, negative 2 over square root of 38. So that is, well, what is that? 7 times, so you can see the denominator is square root of 38. 7 times 3, 21, minus 2 times 5, 10, and then minus 4 times 2, 8. Oh, right? So that's the same as 3 over 38. So far, so good, everybody? Okay, Yeah, remember dot product, you just multiply the coordinates respectively and then add them. Okay, so then now what is the tangential component? The tangential component ATT is then we'll use the 3 over square root of 38 times t. And what is that? So don't forget, this is the magnitude, okay, of the tangential component, and this is the direction of the tangential component. So this is the magnitude or length, this is the direction. So it's a vector. Okay, so when we multiply, we get 9 over 38, 15 over 38, negative 6 over 38. Okay, so here, how do we find the principled unit normal vector? Well, here, because we're not given a function of t, so usually you do t prime over the magnitude of t prime, but here we're not given a function of t, okay? It's not a vector function. We just know the information at a particular point. So we cannot do this method. Well, if you try to differentiate a constant number, it's 0. Right? And we know the fact it's not 0. We don't have the information of the whole curve. We only know at this moment, at this particular point, we know the velocity and the acceleration. But it's okay. We know the fact that acceleration equals the tangential component plus the normal component. So the normal component equals a minus the tangential component. So what is that? Let me use a different color. Just make it colorful. Okay. A, what is A? 7, negative 2, 4. And then the tangential component, 9, 38, 15, 38, 6, 38. Okay. Now, what happened? Oops. I should write more tiny. Now I almost ran out of space. Okay, what is that? Okay, so this steps I allowed you to use your calculator, right? Because you're doing 7, just a common denominator, 38. Then you use 7 times 38 minus 9. And the answer is 257. And then you have 38. You have minus 2 times 38 minus 15. The answer is negative 91. Okay, and then you have 4 times 38 minus 6. The answer is 158. So far, so good? Okay, what is AN? Well, AN, so this is a vector. The magnitude of it is A sub n. And the direction is the principled unit normal vector. Yes. So what is the length of this vector? So 257 over 38 square, and 91 square over 38 square, 158 square over 38 square. So you see the denominator is gonna be 38 square, but when you move out of the square roots, we just get 38. And the numerator, we have 257 square plus 91 square plus 158 square. Oh, such a big number. 99294. Do you have the same answer? So I really hope that when we go over the problems, you can also try those problems first before we go over them. Okay? And then, good. Then what is n? Well, n is this vector divided by this length. Okay, what does that mean? When you divide it by it, your denominator 38 get cancelled, and actually it replace your denominator by this big giant things. So it replaces your denominator from 38 to this big giant square root of 99294, 91 over square root of 99294, and this is 158 of the square root of 99294. Whew. That finished the problem. You might say, wow, the number is so crazy. And I do apologize with it because for this kind of problem, it's hard to find a problem. It's hard to make up a problem that the numbers are so nice and simple. So if you see this such as like crazy big numbers in your exam, don't be surprised. But also you need to check your answer carefully. Okay. All right. So now we have finished the topic about acceleration, the normal components and the tangential components. So far, so good, everybody? Okay, we will continue in the next video, part C. See you soon!